If you've ever thought that some math concepts are, a little intimidating, you've definitely come to the right place. Today, we're going to break down one of the most fundamental and honestly powerful ideas in all of mathematics, the function. So let's just dive right in.
So here's how we're going to tackle this. We're going to build this thing from the ground up. First, we'll get into what a function actually is. Then we'll talk about its inputs and outputs. After that, I'm going to show you a super simple visual trick called the vertical line test. And to wrap it all up, we'll take a quick tour of what I like to call the function zoo.
All right, first things first. Let's get right to the heart of it. What is a function, really? Don't worry, I promise we're going to make this incredibly simple. Now, if you crack open a textbook, you're going to see a definition that looks something like this. A function is a rule that assigns to each element from one set exactly one element from another set. I mean, yeah, that's technically correct, but what does it even mean? It's pretty abstract, right? Let's forget that for a second and think about it a much more intuitive way.
Okay, this is hands down the best way to visualize it. Just imagine a machine. You put something in one side, that's your input. The machine does its thing, follows a very specific rule, and then spits something out the other side. That's your output. But here's the thing. This isn't just any old machine. It has one absolutely crucial, unbreakable rule.
And this is it. This is the golden rule, the single most important thing you have to remember. For any single thing you put into the machine, it will only ever give you one specific thing back. Not two, not zero, always exactly one. That's it. That's the core idea of what a function is.
Okay, so we've got our machine, and we know its number one rule. Now it's time to check out the operating manual, the official names for all the inputs and outputs and how they actually work.
So, in math speak, the collection of all the possible things you're allowed to feed into the function machine, that's called the domain. You can think of these as your independent variables. And the collection of all the possible things the machine could ever spit out, well, that's called the range. These are your dependent variables. Because, well, what you get out depends on what you put in. Makes sense, right?
And this is where it all clicks into place. Whenever you see a graph, you're really just looking at a picture of a function at work. The domain is basically all the possible x values that the graph covers from left to right. And the range? That's all the possible y values the graph hits from bottom to top. It's like a visual map of every single input and the one output it's paired with. Now for my absolute favorite part. A simple visual hack that lets you tell instantly, just by looking, if a graph is a function or not. It's called the vertical line test, and it is about to become your new secret weapon.
Okay, pop quiz time. You're up. Take a look at this graph on the screen. Now, thinking about our golden rule, one input, one output, do you think this thing represents a function? Just take a second and think about it. All right, let's break this down. This is the graph for the equation y squared equals x. So what happens if we pick an input, say an x value of 4? Well, if you look at the graph, when x is 4, y can be positive 2, and it can be negative 2. Uh-oh. That's one input giving us two different outputs. And what did we say? That breaks our golden rule. Big time. And that right there is the whole idea behind the test. If you can take a vertical line, drop it anywhere on the graph, and it hits that curve in more than one place, it is not a function. It's basically a foolproof visual cheat code.
And this slide shows you exactly why this simple little test works so well. See, a vertical line is like a laser beam pointing at just one single x value, one single input. If that line touches the graph in two different spots, it means that one input is trying to have two different outputs. And we know that is a huge no-no in the world of functions.
And here it is, side by side. The difference is crystal clear. On the left, with that straight line, it doesn't matter where you draw a vertical line, you're only ever going to hit the graph one time. It passes the test with flying colors. But on the right, our sideways parabola fails miserably because a single vertical line can easily hit it in two spots. Simple as that.
Okay, you've totally nailed the definition, you've got the test down. Now for the fun part. Let's take a quick, rapid-fire tour through the function zoo and meet some of the common characters you'll run into out there.
First up, we've got the linear function. Its graph is just a plain old straight line, and it represents a constant, steady rate of change. Think about a taxi fare. You pay a flat fee to get in, and then the cost just goes up steadily the farther you go. It's simple, it's predictable, and it for sure passes the vertical line test.
And then we have this guy, the famous parabola. This is the graph of a quadratic function. You see this classic U shape literally everywhere in physics and engineering. It's the path of a ball when you throw it, it's the shape of a satellite dish, and as long as it opens up or down, it's a perfectly good function.
Now for something a little more interesting, the piecewise function. I like to think of this one as having a split personality. It follows one rule for a certain section of its inputs, and then a completely different rule for another section. You actually see this with stuff like cell phone plans, right? You pay one price for the first 10 gigs of data, but if you go over that, you suddenly start paying a different higher rate.
A really famous type of piecewise function is the absolute value function. It creates this super distinct V shape. It's basically following one rule for all the positive numbers and another rule for all the negative numbers, and they meet right in the middle. This is super useful for measuring stuff like distance from a center point, where it doesn't matter which direction you're going. So, let's do a quick recap of the essentials. Number 1, the golden rule. A function has exactly one output for each and every input. Number 2, the domain is all your possible inputs, your x values. The range is all your possible outputs, your y values. And finally, don't forget your new secret weapon, the vertical line test, to easily spot if a graph is a function. So why does any of this matter? Well, because functions are literally everywhere. They're the language that describes the relationships that run our entire world. The time it takes to bake a potato is a function of its size. The grade you get on a test is a function of how much you studied. So I want to leave you with this question. What's a real-world function that you deal with every single day?